A warm welcome to you all for the second session of the video presentation on day 2 of the 70th IFC. We start off with a video of presentation by Dr. Heinz Jürgen Buschner. He is the Managing Director, Head of Industrial and Automotive for IKB Deutsche Industry Bank AG. The topic of his video presentation is Global Foundry Industry, Future Chances and Challenges. This is a very relevant topic in today's world because we see India is number 2 casting producer of the world, and the Indian foundrymen need to know what are the global trends and challenges coming up. So it should be a very interesting video presentation. Let's start.
Foundry Congress, and it's my pleasure to a lot for the great honor. Ladies and gentlemen, thanks a lot for the great honor to give you a brief overview concerning the future chances and challenges of the global foundry industry here at the 70th Indian Foundry Congress. And it's my pleasure to be one of the leading speakers in this great auditorium. During my presentation, I will start at first with a quick overlook on the economic environment of the global foundry industry. Later on, I will show you the development in the iron cast market, following by a brief look on the aluminum and copper cast markets. At the end, I will show you some future challenges in the global foundry industry. My name is Heinz-Jürgen Büchner. I am Managing Director at IKB Deutsche Industry Bank, and we have since more than 5 decades a close relationship to the global foundry industry. And I'm experienced and in contact with leading managers of the foundry industry worldwide since more than 3 decades. So let me start at first with a quick look on the economic environment of the foundry industry. During 2020, the GDP in all major companies worldwide were going down. The only exception of bigger economies was the Chinese economy, which showed a very small growth of only 2.3% in the GDP. In 2021, we saw a strong increase in GDP, for example, in the United States of America, as a result of the strong vaccination campaign started with President Biden in January last year. Within the Eurozone, for example, the GDP recovery was weaker than expected at the beginning of the last year, mainly in Spain, in France, and in particular in Germany. The United Kingdom has not only problems with the COVID-19 pandemic, but also some major problems as a result of the Brexit. The biggest growth of the leading countries worldwide was seen in India, which shows a very strong improvement in GDP. And even during the next years, we expect that India will show higher growth rates even than China or the Western companies of the OECD zone. And for the current year, we forecast a sustained improvement in global GDP overall, but we see also some small risks. For example, in Europe, we saw a lot of problems with the COVID-19 pandemic again as a result of the Omicron type of COVID. And even in China, we saw also some lockdowns. But we are a little bit more optimistic that we will see during the next 2-3 years another recovery in the global GDP. Let me have a look on one of the major important sectors for the global foundry industry, and that's the production of light vehicles. We saw a sharp decline in 2020 with a production volume of only 74.5 million light vehicles worldwide. And even in the last year, it was only a very, very stabilization, not even more. There are only some 100,000 light vehicles produced more than in the previous year. For the current year, we expect a growth rate of 10% in the production of light vehicles, mainly in China, but also improvement in Europe and in North America. In Japan and Korea, we do not see a strong improvement, but we expect also a better development in Southeast Asia, in Latin America, and even in the Middle East, but the Middle East is not so important for the global production of light vehicles. And the production numbers are one phenomenon. The other more important phenomenon concerning the future development is the change towards electromobility. We have a high uncertainty how fast we will see significant numbers in the production of e-vehicles. Look, for example, to the forecast done by the International Energy Agency in December 2020. And they presented 2 trend scenarios for the future importance of battery and hybrid drives. In the so-called STEP scenario, STEPS means stated policy scenario, they adopted regulations and specifications which are used and company announcements worldwide concerning sales plans, concerning new types of vehicles produced during the next years. And they assume that we will see an improvement during the next years, and in 2025, they forecast a production volume of around 15 million e-vehicles worldwide. In the second scenario, the so-called sustainability development scenario, even in 2025, they expect a production of around 25 million e-vehicles in total worldwide. And for 2030, in this case, they forecast a total production volume of around 45 million e-vehicles worldwide. The main regions where they are produced and where they are used are China, Europe, a little bit less important in the United States of America. We see also a higher production volume in India and in some other regions. In my opinion, the truth will be between these 2 scenarios. And I expect that in 2030, we see the production numbers closer to the sustainable development scenario, while for 2025, we are closer to the stated policy scenario. So if we take into account that we will have in 2025 a production volume of nearly 100 million light vehicles worldwide, we expect a production volume of around 20 million e-vehicles in total. And a little bit later, I will discuss with you what are the consequences of this phenomenon for the global foundry industry. This will result in a change in the mix of types of metals used, and we will see a substitution coming from iron cast grades to aluminum cast grades and other lightweight materials. Let me have now a quick look on the medium and heavy vehicle sector. And they show a total different scenario than the light vehicle production. You see during the next years an improvement in the current year and then a stabilization in North America and Europe on the level of 2022 or 2023. In Latin America, we see also stabilization, as well as in Japan and Korea. Southeast Asia, including India, will show a strong improvement. But the most important fact is that we see a total different development in China. China had produced between 2018 and 2020 a lot of new medium and heavy vehicles, and therefore we see a decline in the current year, and during the next years only a slight improvement. The production level of 2028 will not be seen in China before 2028, probably not before 2030. What are the reasons behind this? Stronger regulations in the European Union and in the United States of America, and they require a reduced fuel consumption and demand significant lower emissions of the medium and heavy vehicles. And that's not only the truck sector, it includes also machinery for agriculture, for the construction industry, and for some other sectors. And let me have now a look at some other important sectors for the global foundry industry and the demand for cast products. We are very optimistic during the next years concerning the development of the global construction output. We see a strong growth during the next 10 years, and between 2020 and 2025, we see an average growth rate of 4.5% per year, and in the 5 years after this period, an average growth rate of 2.5%. And what are the main drivers? What are the main markets who will improve? It's mainly the emerging markets. The growth will be driven by countries like China, India, Indonesia, but also in the United States of America. And it's very important that we see a strong improvement in residential construction, and in the long term, infrastructure message will drive growth in the construction sector. We have seen this even in the last 2 years in China. China had a strong decline in GDP during the first half of 2020. It was the first country with a strong lockdown starting at the end of January 2020. And even in the middle of 2020, they started a program to recover the economy with a lot of infrastructure-related investments. And this drove, even in 2020, the drive the recovery of the global Chinese foundries. And the development in the European construction sector was a little bit different. We saw a decline in Western Europe and even in Eastern Europe during the first half of 2020, and then an improvement during the next years. The developments varied lately across the regions. The UK, Spain, and France showed double-digit negative growth rates. In Germany, we saw a stabilization, only a slight decline in 2020, and a strong improvement, mainly coming from the residential construction. And the strong growth which we expect in the next years in the global construction sectors means that we need a lot of investments, mainly in new sewage plants, sewage treatments, water treatment plants. We see a lot of investments in the infrastructure sector, for example, in the railway industry and in some other sectors. Another important sector which will give main impulses to the global foundry industry is the power generation during the next years. We forecast that between 2020 and 2025, we will see nearly a growth of 80% in the global power generation. And it will come from natural gas, even from coal during the next years. Nuclear energy will show growth, but the main growth driver will be renewables. And if we have a look on renewables, we see a lot of demand for the foundry industry coming from the windmills. The windmill industry needs a lot of additional amounts of ductile iron cast for new mills, either in offshore or in onshore solutions. And if we take into account that for 1 megawatt of capacities in a big windmill, you need nearly 20 tons of cast products. So this will be an important driver during the next years, and this will going mainly to the iron cast products. Let me have now a quick look on the development in the oil market. We saw during the last year a strong decline in OPEC investments into upstream. Only a third of the amount which OPEC invested in 2020 was seen. And what was the main reason? The sharp decline in the first half of 2020 in the crude oil prices. The crude oil prices recovers then quickly, and meanwhile they are on a very high level. At the end of January 2022, we saw a crude oil price in the Brent grade of above $91 US, and for the Western Texas Intermediate, we saw a price level above $88 US. And but the sharp drop in the last 2 years ago had the result of lower investments. In my opinion, during the next 2 years, we will see improvement in investment from the OPEC countries as well as from the North American fracking industry. We saw also a sharp decline in the number of active rigs in the first half of 2020. Meanwhile, they recovered at the end of January 2020. We saw around 500 active wells, but it's below the former high levels of industry. What we also see is at the moment a stronger US dollar. Why? And this is the exchange rate between US dollar and the Indian rupee. The main reason why we expect even in the next months a stronger US dollar is the quick recovery of the US economy, but also the announcement of the Federal Reserve to start a tougher monetary policy. And we expect higher interest rates in the United States from March 2022 on, and this will have the result in a quick higher US dollar in relation to major currencies, to the euro, to the Chinese renminbi, and even to the Indian rupee as well. So what does it mean now for the global iron cast market? we started our forecast to take into account the development of the GDP in different regions of the world. We're taking into account the development of the global light and medium heavy industry, and in addition, the development in the foundry industry, as well as in the power generation and the construction sector. In addition, we calculate the effects of changes in mechanical engineering and electrical engineering for the global foundry industry. What we saw in 2020 a sharp decline in production of iron cast products worldwide. And during the current year, we expect only a moderate recovery. And even during the next years, we see until 2025 only a moderate development. And from 2027 on, we see a stronger decline in the necessary production of iron cast products in the NAFTA region, in Western Europe, as well as in China and some other Asian countries. In Eastern Europe, we see until 2025 a stronger recovery that is a result of the development in Russia and Ukraine and Turkey. In Russia and Ukraine, we expect during the next years situation into more peace than in the current situation. And also we expect in Turkey a quicker recovery of the Turkish economy, as well as a very quick recovery of the Turkish foundries. Why? Because a lot of Western European foundries opened subsidiaries in Turkey, and they produce there mainly for the European automotive industry, but also for some other sectors. In the rest of Asia, the recovery will be also moderately, but we see a strong growth in India, in Vietnam, and in the next years, even in Indonesia. This is until now not a big player like India, but it's becoming more important. It's an economy of around 260 million people living there. And therefore, we see in the medium term higher needs for the automotive industry in Indonesia, as well as for other sectors, mainly the infrastructure industry. Let me have a quick look on Europe prior to a deeper look on the Asian market. Within Europe, we see an improvement in the current year in Germany, and in 2025 we see also a stabilization, but then it will go slightly down. The strong growth in Eastern Europe I mentioned until now. We see also a recovery in Italy, and we see also a slight development in France. We see a stronger development in Spain at the moment. Why? We have in Spain a lot of big companies producing cast parts for the global industry, and there are some specialized companies which could produce very, very large cast parts and up to 50 tons per part and even more. And this is an effect which could result in a higher production level in the Spanish iron cast companies. If we have now a look on Asia, we see that India has a high potential during the next years. India has, in my opinion, high needs to invest into infrastructure in the next years, and this could induce additional demand for the foundry industry. We expect also an improvement in the production numbers for the Indian light vehicles in the sector, and even the construction industry will have high investment needs. South Korea and Japan will lose directly market share to the Chinese foundries. And the development of Taiwan is a little bit unsecure. Why? because we expect here perhaps more investment declines during the next years as a result of political uncertainty in this country. But China is even during the next years the dominating player with production volumes above 40 million metric tons every year of iron cast products. Now, let me have a quicker look on the light vehicles industry and therefore on the aluminum and copper cast markets. The lightweight construction will drive recovery of aluminum casting worldwide. We see good growth opportunities. Why? At first, if you produce a car as an e-mobility vehicle, you need the high weight of the battery for the car. For example, a Jaguar has normally a power engine including the periphery components, which weighs around 94 to 96 kilograms. And if you now produce the same car with a battery as a battery vehicle, the new battery has a weight of around 202 to 206 kilograms. So the weight of the battery is more than double as high as the weight of the classical power engine. So if you have such a big battery inside the car, you have to reduce weight on other segments of the part. Therefore, it's a production of light materials necessary. And we will see a strong material substitution process. And in addition, every gram of weight which you can put out apart, you had to put out during the next 10 years, even if you not lose even one part in production numbers. I forecast that you will reduce your total production volume by around 10% only as a result of a strong decrease in average weight of cast products. China has come very good through the crisis, and even the NAFTA was not so bad in 2020, and in 2022 we forecast an improvement of the production volume of 2018. Why? Because a lot of European countries like Spain, France, Germany were strong negatively infected by the impact of the COVID pandemic. And therefore, we have seen, for example, in northern Italy, a long lockdown of aluminum foundries, of iron cast foundries. Even in Germany, in France, a lot of foundries had to close for some months, and this resulted in a strong decline in production volume. In Eastern Europe, we have not seen stronger decreases, with the exception of some smaller production countries, but we have the negative impact of the Russia-Ukraine crisis and the crisis of the Turkish economy as a result of problems with their currency. So for the NAFTA region, we also forecast a greater growth in the medium term, mainly in Mexico, because Mexico is today the low-cost production plant for the United States. What will we see in Europe, for example? We see a strong recovery in Germany during the next years. We see the improvement in Eastern Europe and a strong improvement even in Italy. In France, we will see a stabilization in the next years. And even in Spain, we have a higher growth prospects than in France, for example. In Eastern Europe, it's not only Turkey, but it's also Romania, Slovakia, Hungary. These countries profit from a lot of greenfield investment of Western European foundries for cast products from mainly light vehicles. Today, Slovakia and Hungary are big production plants for light vehicles. Even Romania becomes more and more important during the next years. So let me have now a quick look on the Asian situation. China dominates the production of aluminum cast in Asia with production volumes in the current year of more than 7 million metric tons. And we forecast for 2025 a production volume of around 8 million metric tons in China. We see stabilization in South Korea and a slight improvement in Japan. And we see, in addition here, a difficult situation for Taiwan. And we expect strong growth rates in India. So your aluminum foundries will have, in my opinion, the chance to improve their production volume by nearly 50% until 2027. And this comes mainly in China from the trends towards e-mobility, and even in Japan and Korea, impulses came from e-vehicles production. If we have a closer look on the copper production worldwide, we see very restrained growth numbers. The global copper casting, we see a return to pre-crisis level in 2022, but after then only a sideways movement thereafter. The Asian region accounts for around half of the global production volume. Within Western Europe, we see mainly Italy and Germany with good growth processes for the copper casting. In Italy, it comes mainly from the construction industry. The copper casting foundries in Italy have high design experience, and you find a lot of copper cast products, mainly in bathrooms or in interior solutions. Let me have now a quicker look on future challenges in the global foundry industry and what chances we see for your industry during the next years. I start with a very negative impact. We forecast worldwide a rise in energy costs. And if we have seen the volume here on average in 2020, we forecast a strong rise until the next years until 2050. If we have a look on the electricity costs in India for industrial use, you see that your costs in 2020 were around the average, a little bit below the average of the biggest 100 industrial countries worldwide. And in the next years, we also see a strong growth in your country. We saw a strong growth in electricity costs in India during the last 10 years, and we forecast even in the current and the next years, higher growth in electricity costs. And this will have a negative impact on the margins of your Indian foundries, but only not for the Indian foundries, but also for all other foundries worldwide. Let me have another look on the changes in manufacturing technologies. We expect considerable changes in production technologies, mainly for light vehicles. Tesla has announced that it wants to produce complete large parts for e-vehicles using aluminum cast. And they invested, for example, for the new plant in Germany, in big new casting machines with pressure of more than 6,600 tons. For example, the rear floor plant of this new model will be made of only 4 components instead of around 70 at the moment. And in a further step, they announced that they want to produce a complete floor plan only with 1 cast product. So for Tesla, it makes sense. It reduces the handling costs. They have only 1 more supplier for this casting products, and it will give a total stimulate for the global demand for aluminum castings. I'm in talks with some other original equipment manufacturers, and they told me that some of them think concerning similar investment. That will mean we will see some new capacities for aluminum cast products with very, very big parts. Another important phenomenon is the trend towards finished cast products. And this will become important investments even for you foundries in the next years. The automotive industry wishes not to having to touch the components anymore. Therefore, they favor that they come directly at the assembling line and they can install it. Furthermore, they reduce the number of the suppliers, and in total, they have a significant reduction in logistics costs. And if you have seen the transport cost volumes during the next years, you can understand them. Second, we expect complete post-processing castings, and they have, this was a process we have seen in the last years, mainly in Europe and North America, but even in some Asian countries. And this, even to the future, we expect high investments in new processing centers. And in addition, we will have to invest in surface treatment or in heat treatment during the next years. And the third effect is a cooperation with post-processing specialists will become an alternative to your own investments. But be careful. If you have a partner for the post-processing, the product liability, mainly for the automotive industry, will remain at your own foundry. So if your supplier makes a mistake, you are responsible against the automotive industry. Take this in account if you think about outsourcing. What are strategic challenges for the next years in the global foundry industry? At first, the emerging markets will account for the majority of the demand growth. The automotive industry in particular will demand local production outside Europe. That's good for you and for your production of light vehicles. And increased requirement of global presence will have the effect that you see rising logistics costs. We've seen also a lot of investments of global active foundry companies in India. Look, for example, the investments of Nemak, one of the leading independent aluminum cast companies worldwide. We see high technology changes, and the preservation of technology leadership will be the important fact for your company. Pressure on weight reduction will continue in the automotive industry, but as well as in the machine construction industry. We see also similar processes for mechanical engineering, and the e-mobility discussion will change the global supply chain, mainly in the powertrain. We expect it will become more difficult during the next years to find qualified employees. And one of the members of the Indian foundry industry told me some years ago on an international conference that the foundry industry is called in India a 3D industry: dark, dangerous, and dirty. And therefore, if you have a strong growth in your country, and you have seen the growth numbers which we forecast for you during the next years, it will become more difficult to find qualified personnel and to hold it even. We see strong investment requirements, mainly for production of completely processed casting parts. We see high investments concerning complexity of metal alloys, and we see high costs of energy, which we will have to manage. This will result in a margin pressure. International competition in vehicle construction will go up. This limits the possibility of cost transfer to the end consumers. And you have seen during the last months the process which was not so strong from the automotive industry, but this will change very quickly. And OEMs will pass this cost pressure on their suppliers, and this means on you. In total, we expect a strong industry consolidation during the next years. Main reasons are the globalization pressure and increased investment requirements, which are very difficult for mainly family-owned companies. And many family-owned companies have problems with succession in our point of view. In total means this, the global foundry is facing increased investment requirements in combination with technical changes. This will result in a higher industry consolidation. Growth means not necessarily that we will not see a consolidation in the foundry industry. Thanks a lot for hearing my presentation, and I'm now open for some questions. Thanks a lot.
Anyone who has questions can note down his email ID. You can write to him directly. So we have the last video session coming up. In the interim, I need to take a break for 5 minutes. He needs to pull something out. This is the final video presentation of Professor Han Hazereski. He is a PhD, Faculty of Mechanical Engineering, Department of Foundry Engineering at Silesian University of Technology, Poland. Professor Han is an author on several articles and books, wide industrial experience, conducted metallurgy and finery-oriented workshops, visiting professor in Czech Republic and Mexico, supervisor of PhD theses of students of 8 Indian universities, member of ICME UK, NADCA and TMS USA, Croatian Metallurgical Society and Polish Foundryman Society. He is also an internal auditor for ISO 9001-2000 issued by BSI. The topic of his video presentation is metallurgical quality of the melt as a key of sound castings. Video, please.
for this opportunity to take part. Ladies and gentlemen, dear chair of the organizing committee, dear chair of this session, I would like to thank you for this opportunity to take part in this famous Indian Foundry Congress. It's a pity I couldn't attend in person, but it is due to the changes in the dates of the Congress, which is exactly in the middle of the great our Catholic holidays. So sorry for that, but thank you for this possibility to capture this video and to present in that way our presentation, the presentation of our results. And the title of my speech is Metallurgical Quality of the Melt as a Key of Sound Castings. And this is about the joint effort of Faculty of Mechanical Engineering, Department of Foundry Engineering. I came from. I'm a university professor at this department, and the PGO Foundry Group in the case or in the matter of R&D projects. And let me start with the very short introduction to the place I work at the university. It is in Gliwice, in the middle of Upper Silesia, the most industrialized region of Poland. We have several foundry plants nearby, so that is why we have a foundry department at our university. And here you can see some photos of our foundry department and our team. It is not a big one, but quite effective, I would say. So what does it mean metallurgical quality? I suppose that means slightly different for all of you, yes. But for me is that the metallurgical quality of the melt is the set of the various or different liquid alloy properties affecting the quality of the final casting. And I would say, and I suppose you will agree that if you make it bad at the stage of metallurgical process, you cannot improve the major problems during the next processes. Yes, so the better the metallurgical quality, the better the casting is. So what's the answer when we ask how to improve the metallurgical quality? We think that this is due to the projects, or the way is to make some project on the demands of the industry, because they know the best what are the problems with the quality. So I would like to present the results of two R&D projects. And first of them is manufacturing of the innovative steel castings for extreme operating conditions applications. And it was the project for the PGOSA Pioma Odlewnia. It means Pioma Steel Foundry in Piotrków Trybunalski, and three academic and R&D institutions, and one of them is my university, Silesian University of Technology. It was quite a big project because it was approximately 11 million euros. So for foundry plants in Poland is quite a big project. What's the Pioma Foundry looks like? It was even before the project. It was one of the best Polish foundry plants, and the Pioma is part of the group of foundries, and the steel one. And in the project, we wrote some challenging requirements, like a high metallurgical purity given by the standard K4 parameter, and total oxygen given in ppms, and high chemical purity, in this case given by the phosphorus and sulfur content. And because we were targeting in many cases the low carbon steel, duplex or super duplex steels, so the carbon content should have been less than 0.03%. So the results we expected were tensile strength more than 1000 megapascals, yield stress more than 900, with elongation more than 20, and impact strength for minus 60 centigrades more than 40. And this is this kind of extreme conditions, yes. And remember, it is about the casting, not the metal working project, not drawing, not forgings, for castings. So how to make it, how to produce castings as good as I mentioned. The the most important thing is metallurgy. Of course, the casting mold technology and then forthcoming heat treatment procedures are very important, but the metallurgy is the most. Carbon content to reduce some impurities and so on. So we commissioned the new small one unit, very small, I would say, for the matter of AOD converters. And this is the first installation of that type in Poland. Of course, we needed the gas supply system because this is crucial for the AOD working performance. Oxygen, argon, and nitrogen, stable and very well controlled process. We've changed our induction furnaces. We replaced them with the new ones you can see on the pictures. Obviously, some auxiliary equipments like ladles, heating devices, overhead cranes, because we wanted to be sure that anything will affect badly our high quality liquid alloy from the alloy converter, from the AOD converter. To check the results, to check if these parameters are at the level we desired, we bought the new equipment for the temperature, active oxygen, carbon, aluminum content measurements, for the sampling or the samples taking from the liquid alloy, and of course some real lab devices like testing machines for mechanicals, like machines for notching preparation or notches preparation to check the impact hardness, and the brand new very good spectrometer. But the most important was the process. And to be honest, it wasn't very easy to stabilize the process in such a small converter. Yes, it was a big challenge, not only for us, but for our Swedish suppliers as well. And one of the problems was the time of the process and the time of the particular stages of the process, like decarbonization, but the reduction process as well. And as I said, we've targeted several types or several grades of steels. So here you can see the picture with the average heat time for low alloy, martensitic, and duplex steels. And here you have some some only several examples of the chemical analysis of the steels we were producing to show you how complex was the project, how different were the grades, and how many alloying additions with the added to the steels for the particular grades. And obviously, to be sure that we will obtain the mechanicals at the level we demanded or we wrote in the project, we checked a lot of samples in the matter of the non-metallic inclusions, the precipitations of many phases, etc., etc., to be sure that their level is as low as possible, as low as standards say, and to be sure their shape, size, and distribution is the best. And what else? We checked the K parameter and total oxygen content because they were one of the milestones parameters, yes? So we checked them for all of the alloy, the steel we produced. And here you have the table, the comparison table showing you on the left, the first column, the most important parameters like a K4, the total oxygen, phosphorus, sulfur, and carbon. And in the middle, we have the AOD technology. On the right, we have the traditional, the old technology in the plant. And you can see very substantial and significant improvement. Yeah, you can see that in that case we are not totally, or we shouldn't be totally happy with the results, but these are only the tools. These parameters are in fact the tools to obtain the mechanicals, and I can say we did it. We achieved the mechanicals we desired. And here you can see the basicity of slag from experimental melts in the AOD converter. Those of you who are familiar with the AOD process, you know how important is the basicity of slag. It gives you the information how well could be the stages of the process, and especially the reduction process to reduce, let's say, chromium from the slag after the first stages of the process. As I said, we are happy with the results. We achieved the results. I would say the parameters like a K4 and oxygen and so on, 95% of success, but the real success was in the matter of defects or of the quality of the castings. And I can say that because of the very low sulfur content, we have less hot cracks. Because of the much lower content of hydrogen, no problem, almost no problem with the snowflakes like defects. Very high mechanical properties because of the very low level of non-metallic inclusions in the percentage of the surface of the tested samples. And because of the total oxygen is very low and nitrogen is very low, we can achieve the mechanical properties higher, up to minus 60 centigrades, what was the main goal of this project. So here you have only few examples of the new steels, of the new alloys we could implement into the manufacturing routine of the steel plant. And the examples at the end of this part of the presentation, the railway castings, the oil and gas for offshore and onshore applications, a lot of castings for energy, and many others. And I can say that at the moment, the PGO Foundry is the best such foundry in Poland. The second part of my presentation is about another project, but again focused on the metallurgical quality of the alloy. In that case, of the gray and ductile cast iron. And you can see the title is quite long, but the most important is the ATD or TDA, thermal derivation analysis, which we applied to control our process. And you know, all of us knows that DTA analysis is not the new development, yes, but we still work on it, and we still try to make it better as a tool to improve the liquid alloy quality before we pour it into our molds. And again, you can see PGO and my university and AGH, University of Technology. This was the consortium, or they were the partners, and again quite a huge project. And again some goals we would like to, or we wanted to achieve. In that case, it was completely different because of the different materials. So the foundry has or had the problem with the chunky graphite, so degraded graphite inside the microstructure, the porosity problem, and of course, as usual, too low mechanicals for some superior castings, and of course, as in any R&D project for industry, cost improved product. And again, without major investments, you cannot succeed in such project. And again, I can say the Shrem Foundry was a very good one before this project, but to level to make the next step into the best quality, they had to spend money for the major investments, and in that case, they focused on a alloy additives installations. Why? Because and we felt this is important to dose very accurately and with very good stability the materials, the alloy additions, but the inoculants, the nodulizers as well. So here you have the stations for automated system for introducing inoculants and nodulizer or spheroidizers into the ductile iron during its processing. Brand new furnaces, because yeah, the furnaces can only be the bottleneck, their quality, and of course a very modern Itaka system in that case, Itaka system to control the whole process. And here you can see the device for stream dosing, the inoculant stream dosing by Itaka. And on the left, you can see the cooling curve, because DTA method is based on the cooling curve analysis and derivation of this curve. And here you can see the real capture from the system, camera system, looking inside or exactly into the stream of the liquid cast iron going through the furnace into the ladle, and during this tapping out process, the inoculator is being added into that. You can see the dark color. These are the real inoculant particles. Sorry for that. And the chemical composition of the inoculants. We've checked, I would say, all type of inoculant present on the Polish market. So we can say, or I can say, we checked the whole range of the inoculants. You can see based on zirconium, cerium, ferrosilicon, and so on. So you can see the range of the inoculants. And of course, we focus on some grades of the cast iron. So you can see the charged materials, you can see the average chemical composition of base cast iron and final cast iron. It was mostly the ductile iron of 507 and 600 grades based on the European and Polish standards. As I said, the project was focused on the use of the DTA automatic system to control the quality of the liquid cast iron inside the melting furnace, inside the ladle, and even inside the mold in some cases. So here you can see the red curve, this is the cooling curve, and the blue curve, this is the first derivative, and you can see the bunch of the selected parameters from the Itaka system which give you some information about the let's say overall metallurgical quality of the liquid alloy and the potential of graphitization, the potential of nodularization, what kind of structure you will achieve, etc., etc. And here you can see the table, one of the tables for the inoculants, various inoculants, and the parameters listed in the previous slide. And here you can see what was the range of scatter of this data, and here you can see the curves and the mechanicals. And the table 7 shows the mechanical properties For the typical 500 grade of ductile iron, so the UTS, in that case, sorry, these are our European labels like RM, it is UTS, RPO2 is yield strength, and A is elongation. Yes, so you can see really nice results, much higher in the matter of elongation than it is expected based on the standard. Here you can see the microstructure parameters, because of course we focus on the microstructure as well, because a few minutes ago I mentioned the chunky graphite problem, the porosity problem, so the microporosity as well. So we've done a lot of microstructure testing or metallographic examinations, and here you can see the selected results for the zirconium based inoculant, cerium based, ferrosilicon, barium, rare earth metals based, and bismuth based inoculants. And then several slides showing you the graphs with the influence of the various inoculant on the selected DTA parameters. The parameters are on the y-axis and the inoculants on the x-axis, as you can see here. Here you can see, for example, solidus temperature changes for various inoculants, and the T minimum, which is very important parameters from the crystallization potential point of view. And recalescence and VPS parameter, very important when you consider the shape and the shape factor of the nodular graphite precipitation and so on, and some other parameters like shrinkage and porosity, which are obviously very important from the quality of the castings point of view. We check the macro features of our sample castings, and here you can see the results of this for various inoculants, and the mechanicals for various inoculants, like on the left one is a UTS, and on the right one is elongation. As I said, very nice results. And a bunch of conclusions, but the most important one was that we achieved the goal, and we proved that this is possible in the real industrial condition to control very well the process and to control the metallurgical quality of the alloy before we pour our molds. And we are very happy, and the Foundry is very happy with the results. As I said, we can produce in very stable way the 507 grade of ductile iron, and 600 and 700 as well. So the Foundry now can produce a variety of the castings for very demanding clients. At that moment, I would like to show you the very spectacular success of Polish Foundry. This is the Fox Patris bell. I have no time to explain it further, but you can see here, this is my colleague, the head of our department. Without the help of our department of Foundry Engineering, it wasn't be so great success. And at the end, some conclusions, maybe not completely serious, but very, very important. Castings have a great history. You know for sure that castings are present in our everyday life, around 100 million tons of castings every year. And I'm sure that castings have a bright future. And to be ready for this bright future, I would like to invite you to take part for the conference, our Polish but international conference. It will be 62nd conference this year in Gliwice, where I live, where my university is located. Feel free to check the website. Feel free to ask me personally by email. And yeah, I think you will be very, very happy and very yeah, the conference should be very interesting for you. And because I am a editor-in-chief of the Archives of Foundry Engineering Journal, I warmly invite you to submit your papers. perhaps from this Congress or any other topics, again, feel free to contact me. Here you can see all the data, how to contact me. The most important, of course, is the email. I will answer for sure. Thank you very much for your attention and again for this opportunity. It's a pity we couldn't meet in person, but I believe the next time we can meet, perhaps in Poland in September during our conference. Thank you very much and have a nice day. Goodbye.
So,
Ladies and gentlemen, dear chair of the organizing committee, dear chair of
this brings us to an end to the video presentation session. So we would virtually like to thank Mr. Huster from Inductotherm, Mr. Kuk-Wan Han from Samyong, Dr. Heinz Buschner from IKB Deutsche Industry Bank, and Professor Han Haziraski from Sicilian University of Technology, Poland. I thank you all very much for being patient listeners. Now we can break for lunch. Thank you.
Hello. Yeah, just please be seated for just 2 minutes. We are thankful to Sanjay Bhai for heading the sessions. And now I would request Mr. Vikram Bhai Doshi to felicit Sanjay Bhai. Please. Please. Yeah. Thank you. Thank you very much. Yeah. The session is over. We can continue with the lunch now.